Okay, so make sure that you have done the basics on logarithms and know what they are. Next thing we're doing is laws of log. So it's similar to when you have laws of indices, so you know the little powers. It's sort of like those where you've just got to remember the rules and then you've got to sort of simplify them the best you can. So with these ones, there are 6 main rules that you need to remember. So if you're adding 2 logarithms together, okay, that's equal to a logarithm multiplied together. Now, just a couple of things to make sure. Always check that the base numbers, so the a's, the little numbers, that they are the same. Okay, if they're not the same, then you can't use these rules. Okay, other than that, it's very simple. Also, later on you'll see that sometimes there are numbers at the front of them. You've got to try and get rid of those first before you can then use this first and the second rule. Okay, for the next one, if we're subtracting the 2 logarithms together, that's the same as then just log of x divided by y. Okay, this one's quite a nice one. So if you've got something with a power, okay, that means you can then bring that power to the front, okay, and obviously it works the other way as well. So if you've got a k on the front, you can then put it as the power of whatever number is at the back, okay. Now, I would say 4 is quite similar to 3. It's just making sure that you remember key facts about powers and indices. So it's just knowing that 1 over x is the same as x to the power of minus 1. And then again, that minus 1 can then move to the front of the log. Okay, 5 and 6 are quite nice ones. Again, just one you need to remember. If your number here is the same as the number on the base, okay, it means that that logarithm would be equal to 1. Okay, there will be some harder ones that you'll see later on of when we're doing some questions where we're going to use that but slightly differently. Another one you've got to remember is that if there's a 1 there, doesn't matter what base number, it could be 10, 20, 5, 3, anything. If that has a 1 there, that logarithm will always be equal to 0. Okay, so that one's really important to remember. So using these rules, I'm going to try and fit all of them in. I'm going to go out a little bit. There we go. So I can have the rules as well as the examples. So starting off with the first one. So we need to write these as single logarithms. Okay, so at the moment, most of them are 2 separate ones. Okay. So the first one we've got log base 3 of 6 plus log base 3 of 7. So the bases are the same, which is good, they're both 3. Okay, now we're adding those 2 together, so we're going to be using rule 1. Okay, so all we do is multiply the 2 numbers at the ends together. Okay, so we're going to end up have log 3 and then 6 times 7 is 42. Okay, and that's the answer. We've made it as 1 logarithm. Okay, for the next one, very similar. So we're going to be using example or rule number 2. Okay, they both have base numbers of 2, so we can use the rules above. Okay, so for this one, all we're going to do is do 15 divided by 3. So it's going to be log and 2. 15 divided by 3 is 5. So those 2 logarithms simplify to make that log 2, 5. Okay. Now this one's slightly harder. So we're actually going to be using rule number 3 first. Okay, but we're actually going to do it in reverse. So at the moment we've got this right hand side. We need it to look like this. Okay. So what I'm going to do is I'm going to move the 2 so it's with the 3 there. So it'd be 3 squared. Okay, and similar for the other side, so it's going to be log 5, 2 cubed. Okay, now we can work out now what 3 squared is and 2 cubed is. So this is actually log 5 of 3 squared, which is 9, and log 5 of 2 cubed, which is 8. Okay, and then we're back to similar to e.g. 1a. So we've now got the 2 logarithms, we've got no numbers in front of them, which is good. We're adding, so we're just going to multiply the 8 and the 9 together. So it's going to be log base 5 of 72. Okay. And the next one. Right, so the first one is fine, okay, it's in the form that we want. We're taking away this bit. Now the problem is the 4, so we're going to deal with that first. So I'm going to just rewrite the first bit, the log 10 of 3. Now this 4, using rule number 3, okay, the 4 can go with the half. So it'd be log 10 a half to the power of 4, okay? Now I'm just going to do a little arrow just because I know I'm going to run out of space otherwise. So a half to the power of 4, so a half multiplied by itself 4 times, that's going to give us log 10, so that'll be 1 out of 2, 8, 16, yes, okay? Now there's a couple of things you can do. You can leave it as log of 1 over 16, okay, and then using the rules it means that we then divide them. Okay, I'm going to do it in red just because it's an or, it's your decision what you now want to do. Now I don't particularly like it being a fraction, okay, so I'm going to be using this rule here, okay. So at the moment we've got 1 over 16, so think of the x as being 16 there. Okay, so we can rewrite it as this, log, obviously we've got 10, we haven't got a, to the 16 to the power of minus 1. Okay, so I've just used this rule here, okay, and I've just done this part. So we've got the base of 10 from this bit, okay, the x is the number that was on the bottom of the fraction, which was 16, okay, and we've got a power of minus 1. Now using a mix of both 3 and 4, that minus 1 can come to the front. So it'd be minus log 10 of 16. Now because we've already got a minus there, the minus with the minus from there would actually make it a plus. So log 10 3 plus log 10 of 16. And when you add them, we multiply them, so using rule number 1. So it's going to be log 10 of 48. Okay, now if you hadn't done the red bit, you don't actually need to do it. You would do the same thing, so you minus this part, so it would be 3 divided by, because number 2 says we divide them if we're taking away. So 3 divided by 1 over 16. If you're dividing by a fraction like 1 over 16, your number will be getting bigger and you would still get 48. Okay, so it's your decision whether you want to do that. This is quite good practice because it does use rule number 4. Okay, so EG2. Okay, now these are actually quite nice. They just do get a little bit fiddly, that's all, okay? So we need to write all of these in terms of log AX, log AY, and log A of Z. Okay, so we're actually going to be making them bigger. So the first thing we're going to do with the EG2A, so we've got the x squared, the y, and the z cubed. We're going to split them up into 3 individual logarithms, okay, one with x's, one with y's, one with z's. Now I'm not going to worry about the powers to begin with, okay, so let's split them up first. So log base a x squared. Now at the moment these are all multiplied together, so if they're multiplied it means that they must have been added previously, okay, looking at rule number 1. So add log a of y plus log a of z cubed. Now in the question it says it has to just be log ax and log ay and so on. It can't have powers, okay? So using rule number 3, ones that have got the powers, so the x squared and the z cubed, we're going to bring those numbers to the front because we can do that. So we're going to have 2 log ax. The log y won't change because the y was just on its own, didn't have any powers other than 1. And the z, we can bring the 3 forward, so it'd be 3 log a of z. Okay, and that's all they wanted us to do. So for the next one, I'm going to do it in red because they are a bit squished together. Okay, so at the moment it's a fraction, okay, so it means it's got some division. So we're going to be using rule number 2. So for this to happen, it means that the two logarithms must have been subtracted from each other. So it's going to be log a of x subtract log a of y cubed. Okay, now the first part is fine. That's in the form that we wanted if we look here. But the y cubed isn't, so we need to deal with that. So using rule number 3, that power 3 can come to the front. Okay, and you'll be left with 3 log a y. Okay, so for the next one, this gets a little bit complicated now. So I'm going to deal with the fraction first. Okay, so all of the numerator, so the x and square root of y, is being divided by z. Okay, so we're going to be using rule number 2, okay, to deal with that division. So we're going to have log a of x, the square root of y. Okay, I've kept it in brackets for now. Subtract log a of z. Okay, now at the moment, obviously, we still haven't got the form that we want at the beginning. So what we're going to do is we're going to use rule number 1 to be able to split these two up. So log ax plus log a, the square root of y, minus log a of z. Okay, so it's a little bit closer to what we wanted. But the issue is the square root of y. Okay, so going back to your indices laws, the square root means that it's got a power of a half. Okay, so it's log a y to the power of a half. Okay, the rest of it stays the same. And then using rule number 3, that half can come to the front. So it would be log ax plus a half log a y minus log a z. Okay, and that's the final answer. Now the last one, this is what I was talking about with rule number 5. Okay, so we're going to use this at some point. So again, I'm going to just start with dealing with the fraction part. So we've got x divided by a to the power of 4. Okay, so I'm going to split those up. So it's going to be log ax subtract log a to the power of 4. Okay, so we're taking away because it's a divide in the bracket. Now I don't like this power of 4, so I'm going to use rule number 3 to bring that to the front. So that will become 4 log a of a. Now looking in the question, it doesn't mention anything to do with log a of a's. So this is why I'm going to bring this down a little bit. We come to this one here. So number 5, I said log a of a. So when these two numbers are the same, or the same letter, it's equal to 1. So this part here is just equal to 1. So these are currently the 4 and the log are multiplied together. So we know that the log part is 1. So it would be 4 times by 1, which will just be 4. Okay, and that's the final answer. So just be careful with those sorts of cases, making sure that you look out for them. Okay, otherwise if you did leave it like that, firstly, it's not what the question asks. And secondly, you haven't actually finished simplifying it. Okay.